Awe. All right, let's do this thing and finish it. We have a couple of problems. These are all from an exam paper. Um, let's get done. Yeah, let's get started. So in the diagram below, you have BD. Where is it? BD, right? It's parallel to EF, right? AB, it's parallel to DE, right? BE, where is it? BE is equals to EC, right? And AD equals to 10, right? So yeah, everything that we possibly could need is there in the diagram, right? Cool stuff. So they say show that FC, where is FC? Here it is, né? Show that FC is what? Is equals to 5 centimeters, né? So it's 2 marks, which also say that you don't have to sweat for this one, né? So yeah, here's what I would say we do, né? Let's first focus on triangle. Let's focus on triangle. Come on. I was, yeah, it's this thing. So let's focus on triangle. Let's see, A, B, C, right? Yeah, let me say in triangle ABC. Do you see what is happening over there? E is a midpoint of BC, right? Yeah. So, and we have AB parallel to DE, right? AB parallel to DE, E being a midpoint of E is a midpoint of BC. That means, right? That means D is a midpoint of AC, right? And from D being a midpoint of AC, what does that say? It says therefore DC equals to what? Equals to 10 as well, because now you have 10 here, therefore here for DC you must have 10 as well, so 10 centimeters, né? And now let us shift our focus to in triangle DEC. Alright, so in triangle DEC, which triangle? No, not DEC, no. DBC. Yeah, triangle DBC. Right, you have E being the midpoint of BC. Right, here's E, it's a midpoint of BC. You have parallel lines BD and EF. That means, right, that means here you have F is a midpoint, of what? Of DC, right? Yeah, in that case we therefore will say that DC, which is equal to 10, we show that DC is 10, so FC will then be half of DC, which is half of 10 centimeters, which is going to be 5 centimeters. You see it, ne? So we started first with this big triangle, focusing only on DE and AB being parallel lines. In that case, we will have 10 here, right? We'll have 10, and then we shift our focus, like let's focus on triangle DBC, right? We focus on FE and DB being the parallel lines. Then here you will have 5 units making the 10 units, ne? Let's move on. Now they say if AB, ne? AB, here's AB, they're telling us that it's 16 divided by 5 multiplied by FC. We have to prove that angle ABD or ABC, yeah, ABC, not ABD, this one, we have to prove that this is 90 degrees, right, that it is a right angle triangle. And you can see also with the marks, you're not gonna sweat much. Let's see how we can do it. First, we know what FC is, so we can say AB equals to 1605 multiplied by 5, which is 16 centimeters, right? So on the whole triangle, we have okay, on the whole triangle, I will say AC equals to 20 units. Let's look at AC. We have 10 plus 10, right? That is AC. AC is 20 units. And then we have AB, which is a 16 units. And then we have this one, BC, right? We have BC, which is what? Which is 12 units. And then if we apply theorem of Pythagoras on these, let us see. So AB squared plus BC squared, it has to give me AC squared. Now if I substitute, I go, what is AB? 16 squared plus in fact, let me do it this way, right? Let me say AB squared plus BC squared, that is 16 squared plus BC, which is 12 squared, and is equals to what? Is equals to 16 squared plus 12 squared. We're getting what? We are getting 400, which is equals to 20 squared, which is equals to a C squared. Do you see it? Yeah. So basically, in short, let me get my colors. Basically, in short, AB squared plus BC squared, it gives you AC squared, right? Then you'll conclude to say, therefore, ABC is 90 degrees, because of course theorem of Pythagoras works. Yeah, theorem of Pythagoras, it works. Yeah, your theorem of Pythagoras, it works, right? And because it works, then we conclude that we have a right angled triangle, saying that the angle has to be 90 degrees. Do you see it? Away. Let's work on this one. So this one is 5 marks. They are saying what? Here we are told of this A, B, C, D being a parallelogram, and they tell us that AD and BC are parallel. That is given to us. They also tell us that this is equal to that. They tell us that these opposite angles are equal, right? And then we have to prove that this shape that we have here, it is a what? It is a parallelogram. Yeah, we have to prove that the shape that we have ABCD is a parallelogram. What we know is that ABCD is a quadrilateral, right? So first and foremost, I'm thinking congruency. One of the best way to prove that a quadrilateral is a parallelogram is congruency, because from it you will get to say, this side and this side, therefore they are equal. And of course we have already shown that they are parallel. So then you are done, because you have a pair of opposite sides being parallel and equal. So good. Now, so we will say in triangle A B C and triangle A, or let me start by saying triangle CAD. Here's what's happening. Here's what's happening. So I will start with angle B equals to angle D given. Then I'll go with, look at this. So these are parallel lines, right? These are parallel lines A, D, and BC. Therefore, this angle alternates with this one. So we'll say angle A2 equals to angle C1, right? Alternating angles, AD parallel to BC, right? And then the last thing, of course, we have AC. You can just leave it as AC or just write AC equals to AC, and then you also it's a common side, right? So now you are seeing that, okay, we have side, and therefore this is congruency. So then we'll say triangle ABC is congruent to triangle. Remember, now you have to be very careful with how you would put your things. So you have AB, that means we must have something like CD, right? And then we have AC, right? So it will be CDA, right? So you have CDA, that way BC and DA, DC as well, and AB, right? And AC, CA, common side. Then it is perfect. Then from here, from congruency, you can then say therefore, right? Therefore, AD equals to BC, right? And then here you can just say from congruency, congruency, or you can write triangle ABC congruent to triangle CDA, right? So yeah, you can say from congruency, or you could just say that triangle ABC is congruent to triangle CDA, right? So now alright, let's go for this one. Another thing we can also say from congruency, BA or AB, let me say AB is equals to what? CD. Also, the reason you would say triangle ABC is congruent to triangle CDA, right? Or you can just say from congruency, right? So now from these two, we've shown that this side and this side are equal, this side and this side are equal. So then you will say, since both pairs of opposite sides are equal, right? So both pairs of opposite sides are equal, and AD is parallel to BC, right? A, B, C, D must be a parallelogram, right? Yeah, so we used congruency was able to help us to say that AD is equals to BC and DC equals to BA. That way you have a pair of opposite sides being equal, right? And then with a pair of opposite sides being equal, we have a pair of parallel lines also, right? To top it up, yeah. So yeah, so that those are correct properties of a parallelogram. You see, those are properties of a parallelogram. And let me see. Yeah. Look, the other method is quite long, where now you construct another what is this, another diagonal. Yeah, but I like making things easier because they are easy, so we're not trying to complicate life. Yeah, let's move on. Oh, this is a beautiful one. This is a beautiful one. So they tell us now that A, B, C, D. Where is A, B, C, D? We have A, B, C, D. It's a parallelogram. So by it being a parallelogram, this is parallel to this. Maybe let me put 3 of them because yeah. So this is parallel to this. We can also conclude that this is parallel to this by it being a parallelogram, right? And then beautifully enough, there's a word I never really actually, when we were talking about the properties of parallelograms, I didn't get into the word itself, bisecting, because we for most of the quadrilaterals we spoke about diagonals bisecting each other. Yeah, there was a thing of diagonals are bisecting each other. And here's a thing: for bi we have bi 2, right? And then sections, right? So when I was doing the preparation, actually I also realized, oh, okay. So when we say that diagonals bisect each other, we're saying that the diagonals, they cut each other into halves, right? Yeah, into two halves, like two equal parts, right? So even the same is true when we are talking about angles as well. We'll say this line, it bisects this angle. In short, we are saying that this line, it divides our angle into two equal angles, right? So yeah, we are seeing that here they say BH. Here is BH, ne? BH, it bisect ABC, implying that these two angles are the same, so we can say x, right? Because both of them are the same. Yes. And HC, it bisect BCD, right? So I could say we have y here, we have y here, ne? Yeah, and then try it. Oh, angle ABC. They say it's what, 60 degrees. If that angle is 60 degrees, that means x is what, 30 degrees. X is what, 30 degrees, right? Together they make 60 degrees, ne? And now they say f is 120 degrees, and here's f, ne? 120 degrees. Beautiful. And then of course telling us about the parallel lines, and AD is produced. Where is AD? AD, here it is. Yeah. Let me see what else. Right. Then 30 centimeters, and then BC is produced to F. Alright. Cool. Now they say the first question, prove that C is equals to 60 degrees. And this thing is 3 marks, so you won't have to sweat a lot here. We are proving that C1 is 60 degrees, ne? Yeah, C1 is 60 degrees. So let's look at our diagram carefully. We look at our diagram carefully, ne? Mm. Hmm. All right. Cool. So here's my way of doing it. I think there are about probably 3 if not 4 ways of doing this one. So I'm thinking, I'm like, look at this shape and this whole shape. So we know that DC, wait, DC is parallel to BA, right? That's what we know by this shape being a parallelogram, and let me start this way. I will say that AB is parallel to DC, right? Opposite side of a parallelogram, and then I would also say, then look at angle F, angle F plus angle ABC, it must be equals to 180 degrees. No, I'm not saying that. So angle F is 120 degrees, and then plus angle ABC, we were told that is 60 degrees. You get an answer of 180 degrees. So angle F, this angle F plus angle ABC, it gives us 180 degrees. Then you would say, but angle F and angle ABC are co-interior angles. They are co-interior angles, right? Therefore AB must be parallel to FE, right? Yeah, so from this angle and this angle, adding them together, it gives me therefore FE is parallel to AD, right? And because from here we said AB is parallel to DC, that means FE will also be parallel to DC, right? And then from now on I go on and say angle F, let me come this side. So I go on to say that angle F, right, is therefore equals to, angle F equals to angle BCD, right? And the reason I'm saying that is what corresponding angles, right? FE being parallel to CD, right? And then I have 120 degrees equals to y plus y, 2y, 120 degrees, 60 degrees equals to y, right? And C1 equals to y, therefore C1 equals to 60 degrees, right? Yeah, cool stuff. So now these guys, they say show that BGCH is a rectangle. Remember, this is 2 marks. It like the marks, they also gives you a clue, they give you a clue. If you can't find the easiest method, it's okay, you can use the longest method. Yeah, but yeah, so remember, rectangles, one of the things that are very unique to rectangles is that they have an angle of 90 degrees, they have an angle of 90 degrees. And looking at this diagram, because of BH being parallel to GC, right, we're gonna have alternating angles, ne? So for example, this is gonna alternate with this, right? Or maybe what is I want to say, yes, this angle, it will alternate with this one, right, implying that here the angle here, it's gonna be 60 degrees. All right, so let's do it. You have HCB, yeah, angle HCB equals to angle GBC. Reason, alternating angles, right? Therefore 60 degrees equals to GBC. Yeah, cool. And then you have angle HBG, angle HBG equals to 30 degrees plus 60 degrees, which is 90 degrees. Ne? When you add these two, right, and let's see, so you have 60 here, ne? You have 60 here. Now you see that this angle alternates with this angle, right? So you write the same thing again, and you see that the angle, they alternate, and therefore the angle here at the corner is 90 degrees. So then after showing all of that, you will say, therefore yeah, BGCH is a no, we are not proving that. We are proving rectangle is a rectangle. Then the reason will be all interior angles are equal to 90 degrees. Yeah, all interior angles are equal to 90 degrees. Damn. Yeah. Let's cook this one. So on this one, in the diagram below, PQ, this is interesting one. Let's see. P is PQRS. Yeah, PQRS. That is a parallelogram, right? And we have the diagonals there, PR. We have QS. Wait, QS. Yes, QS and PR. These are the diagonals of this parallelogram, and they intersect at point M. B is a point on PQ such that SBA and RQA are straight lines. So we have SBA, we have RQA. They are straight lines. You have SB being equals to BA, right? So this equals this. Yeah, SB equals to BA. And then SA, it cuts. Where is SA? Here's SA. It is cutting PR here at C. and then we have PA, right? And then PA is drawn. Cool. Now the first thing do like prove that SP equals to QA. We are proving that this equals this. That's what we are proving. For this guy, let's focus on this triangle. Look at triangle A RS. What do you see? You have parallel sides and you have B, which cuts SA into equal sides, right? So therefore there's a midpoint theorem, right? So you will then say that Q is a midpoint. Q is a midpoint of AR, right? Therefore AQ or QA equals to RQ. Yeah, and then you also know that you would say RQ equals to SP. And why are we saying that? Remember we were told PQRS is a parallelogram. So we'll then say opposite sides of a parallelogram right? So opposite sides of a parallelogram, we know they are equal. So now we come to the conclusion to say we are then going to say therefore what since PS equals, let me say SP, since SP equals RQ and QA equals to RQ, SP must be equals to must be equals to QA. Right, yeah, that's how we got it done. And then here we are proving that SPAQ is a parallelogram, right? We are proving that it is a parallelogram. See, SPAQ, yeah. Let me remove this. So now look at the diagram. One of the things is you can even draw it aside so that you can have a clear picture of that particular shape, right, which we are trying to prove is a parallelogram. So look at it very carefully. Yeah, so looking at the quadrilateral, let us look at SP. What is SP equals to? Right, SP equals to QA, right? And this is where did you get this information from? It was proven from the previous question, right? Or here you can just say from 9.2.1, right? Any way you put it is fine. And also let's look, right? We would then say what? SP SP, it is parallel what? It's going to be parallel QA, right? And the question is now, why are we saying it's going to be parallel to? Why are we saying that? Why am I saying SP is parallel to QA? Right, this one, it shouldn't be a tricky question, right? If you look, let me say this. RQ, ne? It is parallel to SP, ne? But you also realize that RA is parallel to SP, ne? Yeah, so I want to say here, the reason I want to say it is given, right? It is given because then because what is happening is that RA, the line RA is equals to line RQ plus QA. So if this is parallel to SP, it must mean this is also parallel to SP and this is also parallel to SP, right? Yeah, so we would leave it there, and then we would then conclude to say, therefore, that shape SPAQ is what? Is a parallelogram. It is a parallelogram. And then the reason why we are saying it is because we have at least one pair, at least we have one pair of side or opposite side equal, right? Equal, and not just only equal but parallel. Yeah, not just equal but parallel. Away. We have another one here. They say proof show that AR is equals to 4MB. Yeah, 4MB. So where is MB? Here it is, this line over here. There we go. So let me get rid of this. So we look at that point. Okay, or perhaps let's start here. Focus on point M. Focus on point M. Let's think, what is point M? So you know point M, it is what? It is a midpoint. Midpoint of what? It is a midpoint of PR. Let's look at, where is PR? Here is PR, and then M is a midpoint of PR. Remember, there's a parallelogram, and then when the diagonals bisect each other, or let me just say when the diagonals, okay, diagonals of a parallelogram, they bisect each other, meaning that the intersection on the point where they all meet, that is the midpoint of each diagonal. Yeah, let's now look at B. Do you think B is a midpoint? It is. B is also a midpoint of what? It's a midpoint of PQ. And the reason also is, like, remember the question, we were proving that SPAQ is a parallelogram. So then the diagonals here, they intersect here, right? Yeah, they intersect here. So yeah, self-explanatory. Then now let us move. Let's look at MB. MB as a line, it's going to be what? MB as a line is going to be twice what? Think. It's going to be twice QR. Let's look at QR. Here is QR. Here is MB. So in that way, our focus is in triangle PQR, where we have this line, right? Because now here this is why. So this theorem, it comes from midpoint theorem, and the reason why we are saying midpoint theorem applies in this situation is because of we have a midpoint of PQ here, which is B, and we have a midpoint M, which is a midpoint of PR, right? So that means the midpoint theorem must apply, and therefore this side is going to be twice this side. Do you understand? Cool. So yeah, where is AR? Here is AR, here is AR, right? And now let's move on, right? We're not going to say oh, I can ask a question. Oh no, no, there's a young error here, there's a young error. Look at this side. So this side, it is smaller than this side, right? So therefore this side is half. Yeah, if I want to write it with Q, I can say QR is 2 MB. Oh my god. Yeah. So yeah, slight mistake there. MB is going to be half of QR, right? So if we look at QR also, or perhaps let's just pause for a second, right? Let us pause for a second and let's talk about AR. Let's talk about AR. So look, we have this, AR is equals to what? Is equals to QR plus Q plus QA. That is what AR is. Here is AR, and AR is equals to QA plus AR. And you will agree with me that we did prove that QR equals what? Equals QA. This is something we proved. So this being the case, that means we can then say AR is equals to what? 2 QR. That makes sense, Doesn't make sense. Let's see. We have an AR here. Here's AR. AR comes from adding QR and QA. And since QR and QA are equal, we can just say AR, this AR is equals to 2 QR. Right? And therefore from here, QR is gonna be what? Half AR. So now we take this and we go down here and say therefore MB is equals to half multiplied by half AR. Do you see? 1 over 4 AR. And then you have proven we have proven that AR what am I saying here though? We just have to I mean, I think it's fine, we can leave it like this. Yeah, but just for the sake of perfection, we multiply by 4, and therefore you will have a r being equals to 4 MB. Yeah, you know how other people, they're so strict, so they could say like, no, if you leave it like this, you're gonna lose a mark, this that. So you don't want that. Yeah, let's do this one quick one. It's 6 marks, but I promise you it's a very easy 6 marks. Yeah, well, so the first one, we're proving that v2 here is v2. We are proving that it is going to be 90 degrees, ne? Cool. I want to show you guys something. So we have ST and QR being parallel, ne? ST is parallel to QR, ne? And if that is the case, therefore y plus x equals 180 degrees, and my reason will be co-interior angles, right? Yeah, you can even go by and say q1 plus q2 plus t1 plus t2 equals 180, and then you substitute the x's and the y's, so you get 2y plus 2x equals to 180, right? And then y plus x gives you 90 degrees. Do you understand? Cool stuff. So also, now let's do this, ne? Look at this. We have a parallel line, right? We have or maybe how do I do it? Okay, let's focus on these parallel lines, RS and QT. Then you would realize that this alternates with this, ne? So you will then say Q1 equals to V1, ne? Alternating angles, right? And therefore x equals to V1, ne? On the same parallel lines, now look at which ones. Let me see. Yeah, the same parallel lines. Look at this angle and this angle, they alternate, right? Then you will say T1 equals to V3 alternating angles, right? Therefore y equals to V3, right? And then after you have that, you will say V1 plus V2 plus let me say V3 plus V2 equals to 180 degrees. The reason will be angles on a straight line. Angles on a straight line, right? And then V1 we did say that is x, V3 we did say it's y, and V2 180. Right, these two we have shown here that they are 90 degrees plus V2 equals to 180, and then V2 equals to 180 minus 90 degrees equals to 90 degrees, and there, just like that, you are done. Alright, so we'll remove everything. We have now, they say RS, ne? Prove that RS is equals to 2RQ. So let's look. RS, where is it? Let me get rid of okay, so this thing is, ne? Okay, let me I just shown, or I just proved that this is y, and here I just proved that this is x. They say show that rs, this whole line, is equals to 2rq, ne? Cool. So q1 equals to v1 equals to x. That was proven, ne? Therefore right, should I even go there? No. Yes. So this, it was proven, what that will mean, it will be rq equals to rv, right? So, and the answer will be, or the reason will be, yeah, triangle QRV is an isosceles triangle, ne? And then let's look again. We proved again, right, that v3, or let me start with t1 was equals to v3 was choose y, right? And therefore, this was proven. And then in this triangle, so for triangle, then you're gonna have, because now you have y, so this will be the same length. So now you're gonna have SV equals to ST, right? And then you will say triangle VST is an isosceles. Yes, it's an isosceles triangle, right? And now we have everything that we all need, né? We have everything that we all need. I can then say RQ. Let's look at it. Here's RQ, né? RQ, RV, they're equal, né? Do you see that? Cool. SV, ST, they're equal. Do you see that? So this and this, and then that is shown, né? So now what this would mean, is, or maybe before we go to what this would mean, we are told that this is a parallelogram, né? Then we can then say, yeah, right, is fine. We can then say RQ equals to ST, né? And then you'll just say this is opposite side of a parallelogram, right? And then therefore it seems RQ equals to ST, right? Yeah, equals to ST, right? ST, right? And then what am I saying? I'm basically writing what I have then. Okay, let me, so RQ equals to ST, ST equals to SV. Well, this one we proven. This equals to this, and this equals to this, right? And then here I go again and say RQ equals to RV, right? Equals to RV. Therefore P Q equals to RQ equals to SV. Ne? And then from all of that, I will then say what? I will then say RS equals to RV, right, plus SV. That is what RS is. Ne? RS is RV. And then now look at this. What is RV equals to? It's equals to PQ. So I will say P, not P, man, RQ. What is SV equals to? Right? So let's go again. Let's go. So we have ST, which is equals to RQ. And then that ST equals to SV. That means SV equals to what? Equals to RQ. So then I'll go plus RQ. Ne? Saying therefore RS equals to 2RQ. Yeah. We didn't even use a calculator, but yeah, that is Euclidean geometry for you. So for this one, I know it can be a little bit challenging. I will do like a video where for each problem I will try to do all possible solutions so that we all have a better understanding. But so far, this will be the end.